Welcome to the demonstration of our tool dtControl, which can help you represent your controller as a decision tree. To understand why you want to do that and how that works, let's take a look at the big picture. Assume you have a cyber-physical system and you have already synthesized a controller for that with your favorite tool. And now you want to execute this controller, often on an embedded device with limited memory, or you may also want to understand the controller in order to improve it or to validate it. Even if the controller is formally verified, there is the very real possibility that the physical system was modeled incorrectly or insufficiently, and understanding what the controller does is very helpful in making sure it does the correct thing. Now, how does such a controller look? It can, for example, look like this. This is a controller produced by Scott's for an automatic climate control system with 10 sensors and 2 heaters. And as you can see, it's a huge cryptic lookup table with thousands of lines, and a human has no chance of understanding this. And additionally, such a lookup table might be too large for the memory of the device where we want to execute it, especially for more complicated models. So, as we just saw, understanding and executing a controller is difficult. But dtControl comes to save the day. So how does it do that? Let me show you. Of course, first we have to install dtControl, which works by just typing pip install dtControl, assuming you have Python 3. When the installation is done, we can call the tool, give it the model file as input, and use one of the many algorithms that the tool supports in order to construct a decision tree. If you are more interested in the details of these algorithms, you can visit our website and look at the documentation, or you can have a look at our HSCC tool paper. But right now, what we want to see is what happened to this huge controller that we started with. So let's go to the output folder. And we see that dtControl has produced 2 files for us, a C file and a dot file. Let's start with the dot file, which is there for visual representation. I just converted the dot file to a PDF, so let's take a look at that. Here we see this beautiful decision tree. This is a safe controller for the climate control system. Earlier we had this huge obscure lookup table, and now we have a tree with 3 decisions, and it's really easy to interpret that. It says that if room 1 is cold and room 4 is cold, then you turn on both the heaters. If on the other hand room 1 is warm and room 4 is warm, then you do not turn on the heaters. For mixtures of the temperature, you turn on the appropriate heater. So we can actually explain what is going on here, and we see that the controller makes a lot of sense intuitively, which was impossible before. Moreover, we realize that we don't need sensors in 8 of the 10 rooms, but just in room 1 and 4, and thereby we can save costs. We also got the C file from dtControl, which has a one-to-one correspondence to the picture you just saw, in that we have these if-else statements that correspond exactly to the decisions in the picture. For example, here we see if room 1 is too cool and room 4 is too cool, then turn on both the heaters. So if we go back to the big picture, we started with this huge lookup table, and then dtControl gave us the small C file to execute it, and the dot picture to understand it. If you're interested and you now want to know more about the tool, you can visit our website or write us an email. Thank you for listening, and goodbye.